Saturday, and that means we're down at the Imagination Station. I have Carl Nelson with me, and Carl, it is now March, and we're hearing a lot of the sounds of spring out there, and I know that we're going to be talking about sound in some form today.
We are. There was a German physicist called Ernst Chladni back in the late 1700s who discovered a really interesting way of observing how things vibrate.
Okay.
So this is just an aluminum plate, and I have a bow here, and if I draw the bow against the side, we can get it to resonate, we can get it to vibrate, but we don't know anything about how it's actually vibrating. Is it just moving up and down? Is it twisting? I don't know. You have some salt there in that salt shaker.
Okay.
Go ahead and just liberally cover the top. I mean, really, all over.
Really get it going?
Even coating.
Okay.
That's perfect. Okay.
All right.
So now we're going to do the same thing, and if we get it to vibrate...
Oh, wow.
Maybe a little bit too much. Let's get that off. But you get the idea here. We're getting these places on the plate. Wherever the salt builds up, the plate's not vibrating.
Oh, okay.
So it's vibrating here up and down, not vibrating here, vibrating there up and down.
It almost looks like a starburst. If you can't see it at home right now, it looks like a starburst.
Go ahead and put your finger right there on the plate and just
Like
gently on the edge, just like this.
On the edge.
You're going to stop the plate from moving right there.
Oh, wow.
Well,
so that really changes the way that it looks.
A little bit, yeah, okay. You know what, let's move on to a different one.
Okay.
You can actually stop where the plate is vibrating. So, for instance, a square plate, give me a dose of sugar or salt there. And we'll do the same sort of thing. Different plate, different vibrational modes.
Ooh, okay.
So now we get something that looks like an X.
Yeah.
All right, we'll save that one.
Okay.
Load this one up again. We'll try a different way. So the plates can vibrate in a variety of different frequencies, or we call vibrational modes. Try to get a different one here.
Oh, neat.
Okay, so that one has not only a plus, but an X, and you see some buildup.
Sure.
Right? So the plates are vibrating in very, very complex ways. In fact, this is my favorite one, the oval. Load this one up.
Okay.
And so Ernst actually got the title sort of like the father of acoustics for understanding how glass or metal plates vibrate by doing this very method. Maybe too much salt.
Sorry, went a little crazy.
That's okay.
Oh, wow. That's really, it almost a little half moon shape.
Yeah, and what's really cool is this is vibrating up, this is going down, this is going up, this is going down. So the plate vibrates in very complex patterns.
So in theory then, or maybe in reality, this is what's happening when you hear those sounds, whether it be music or you're playing an instrument?
Think of a cello or a violin and how they have to move in complex ways. In a classroom, you could actually connect this up to the basics of a speaker, a vibrator here.
Right, okay.
And we can actually tune in some different frequencies. So let's see if we can get this to vibrate in one mode. Okay, we got two lines.
Yeah.
Now if we change the frequency a little bit, went a little bit too high, a little too crazy.
So
you get the idea.
Really move.
You get the idea. You can see you can actually dial in different frequencies to get different modes of vibration on the plates.
And the salt really helps you
The salt
see it.
helps you visualize it because you actually see where it's not vibrating, which is where the lines build up.
Wow.
So it's pretty cool.
The science behind the sound. Who knew?
Yeah.
Thanks so much, Carl.
Sure.
Of course, Saturday, you always learn something fun here on 13 ABC Action News. And of course, it is Saturday. So we want to let you know, if you are a Lucas County resident, paid adults can bring a child for free if you live in that area. And of course, we're always learning something fun. That's how you imagine it.